we're going to look at three different identity groupings that are going to be important for you as you move through the rest of pre-cal and then on to calculus. Now the first set of identities are the reciprocal identities, and I want you to understand that what an identity is first. An identity says that there's this relationship where if I want to replace one thing, I can replace it with the exact same or equivalent statement. So if we're focusing specifically on our reciprocal identities, then if, let's say, I wanted to talk about sine theta in an expression, but I don't want to talk about sine for whatever reason, instead it's going to be more important for me to replace sine with 1 over cosecant theta. Well, because they are equivalent to each other, I can just replace sine in that expression with its reciprocal identity of 1 over cosecant theta without ever changing the integrity of the expression or the equation or something like that that I'm looking at. Now we've really already identified the reciprocal identities. We kind of used these concepts when we were defining our trig functions, and so we're pretty familiar already with the reciprocal identities, I believe. Let's move on to the quotient identities. The quotient identities are kind of fall from, and they might make a little bit of sense in light of their reciprocal identities, in that if I have tangent of theta, that's the same as sine theta over cosine theta. And if you think back, sine theta, talking about our definition of trig functions, sine theta was defined basically by kind of y, or y over r, and cosine's defined as our x's, or x over r. So it makes sense then for, and then tangent, by the way, was defined as y over x. So it kind of goes along, and it supports the idea that if tangent's defined as y over x, then it can also be defined as sine theta over cosine theta. And then because cotangent's the reciprocal of tangent, we can see its quotient identity is simply flipped as well. Now the last set of identities that we want to pay particular attention to have to do with the Pythagorean identities. And these are going to become helpful to us in a lot of things that we want to replace. But notice that these three Pythagorean identities are taking a squared relationship between two particular function values. So in the first one, we have this relationship for sine and cosine, and we say sine squared theta plus cosine squared theta is equal to the number 1. We also have tangent squared plus 1 is equal to secant squared, and 1 plus cotan squared is equal to cosecant squared. So you need to start memorizing these three fundamental sets of identities to be able to have that memorized by the time we get into calculus. Another thing that I want to point out, and we're not going to discuss it in this particular video, is the fact that with any of these identities, it's not unusual for us to rearrange the identity and to manipulate it and put it in a form that might be better suited with what we want. So each of these identities can be rewritten kind of like solving the equation, so to speak, for a different form without changing the integrity of the identity themselves. So we're going to take these identities and we're going to apply them to this example that we have going on down here. But we're going to solve this example actually in two ways. So the first way that we're going to solve this example has to do with using these identities. So I want to find sine and tangent, but I'm only given that cosine theta is the negative square root of 3 over 4, and I know sine theta is greater than 0. So what all does that get me? Well, in evaluating the given information that you see down here, we can kind of get a picture of what quadrant theta is lying in. We need to know what quadrant it's in so that I know whether to assign it a positive or a negative value. So if we just first start with the fact that sine theta is equal to positive, or sine theta is greater than 0, that indicates that if sine is greater than 0, then sine has to be positive. So if sine is positive, we must be looking at a sine that's either in the first quadrant or second quadrant, because remember, sine is positive in these two quadrants. The second key bit of information we have is that the cosine of whatever angle we're talking about ends up being negative. Now, Cosine is negative in the third and the second quadrants. So cosine is only negative here in the second and the third quadrants. So where do these two concepts overlap? Well, if we have to say that sine is positive and yet cosine is negative, then we can only be talking about theta being in the second quadrant. So that's going to tell me then that my sine value that I'm looking for is going to be positive, and my tangent value that I'm going to be looking for is going to be negative, because that's the values those functions have in the second quadrant. So now we're going to use our identities up here to be able to solve this question. So if you're looking up here and I want to be able to pick out of any of these identities something that's going to help me find sine and tangent, some of you may be tempted to see this identity right here. It has sine, cosine, and tangent, all the things that are in my problem down here, and you might want to think that you're going to use that one. Well, we can't use that particular identity because the only known value that I have from my expression or from my question down below is cosine. So although I can plug in a number for cosine, I still have sine and tangent unknown. So that's too many unknowns to be able to do any help for me. So instead, what we're going to do is we're going to come over here and we're going to look at sine squared plus cosine squared is equal to 1. Now, in that identity, that Pythagorean identity, we know cosine because it was given to me in the problem. We have the number 1 because it's given in the identity, and the only thing now that's unknown in that identity or statement is sine. And that's one of the questions that I'm trying to solve for, is sine. So because I know 2 out of the 3 components of this identity, it's going to be the best choice for what I'm going to use. So I'm going to come down here and I'm going to rewrite my identity. Sine squared theta plus cosine squared theta is equal to 1. And I'm going to replace cosine squared, I'm going to replace cosine squared with negative square root of 3 over 4 plus negative square root of 3 over 4. But the identity tells me that I am actually squaring whatever cosine is. That's all equal to 1. So then we're going to simplify this a little further. Sine squared theta plus, if I square the numerator, I get 3, and when I square the denominator, I get 16. So that's equal to 1. Now I'm going to subtract 3/16 from both sides. Sine squared theta is equal to 13/16. And just like if we were solving for the variable x, if x was squared, we would take the square root of both sides. We can do the exact same thing when we're solving for sine. So the sine of theta is going to be the square root of 13 in the numerator, and the square root of 16 happens to just be 4. So we rewrite the square root of 13/16 as the square root of 13 over 4. Now, when we take the square root of a number, we normally allow for both the positive and the negative values. In this case, because we already identified that theta was in quadrant 2, we're only interested in the positive values for sine. So that's the solution for the first one. Now we got to figure out what tangent is. So if we come back up here, still only using identities, and we try to figure out of the identities, what can I use to solve for tangent, now we can go back and use the quotient identity because I have 2 out of the 3 things known. I know what sine is, I just found it. I know what cosine is because it was given, and I'm looking now for tangent. So coming over here, we've got tangent theta is equal to sine theta over cosine theta. We're going to replace sine theta with the square root of 13 over 4 because that's what we just found out it to be down here, divided by the cosine of theta, which was negative square root of 3 over 4. So this is a complex fraction, but it's all right. We can solve those. all we do is we take the numerator fraction, so that's the square root of 13 over 4, change it to multiplication and multiply it by the reciprocal of the denominator, or let's switch the denominator fraction. So negative 4 over the square root of 3, and we multiply straight across. Our 4's are going to cancel. This is going to give me negative square root of 13 over the square root of 3. Multiply top and bottom by the square root of 3, and I get negative square root of 39 over 3. So using fundamental identities, I was able to solve for both the sine and the tangent of the problem. Now, this is specifically using fundamental identities, and I want to, let's see, I want to identify this identity. This is the identity method of answering this question. Unless you are specifically asked to solve a scenario like this using identities, it actually is much easier for us to use our definition of trig functions, which we've been practicing, definition of trig, which we've been practicing up until now. And let's do that using what we've already done before, just to make sure we get the same answer, so that we can kind of compare these two things. We know that the cosine is negative square root of 3 over 4, and we know that my angle is in quadrant 2. So if cosine of theta is negative square root of 3 over 4, and we are in quadrant 2, remember we're over here, so this is theta. We know that cosine is defined as, I'm going to get rid of this out of my way, we know that cosine's defined as x over r, so this then tells me that x is equal to negative square root of 3, r is equal to 4, and we need to figure out, if we're using our definitions, we need to figure out what y is. So rearranging Pythagorean's theorem, we find that y is equal to r squared minus x squared. So replacing r and x with what we're given here, we have the square root of 4 squared minus negative square root of 3 squared. So that's going to be 16 minus 3. 16 minus 3 is the square root of 13. So the question says, what is the sine of theta? Well, the sine of theta is defined as y, which is the square root of 13, all over r, which is 4. And tangent of theta, by our definitions, is defined as y, which is the square root of 13, over x, which is negative square root of 3. Can't leave that negative sign, or I can't leave a square root of 3 in the denominator, so this becomes negative square root of 39 over 3. And I did that kind of quickly because technically we've already solved this, but what I want you to see is that it doesn't matter whether I chose to use the definition of our trig functions, x, y, and r method, or if I'd used the identity method, the sine of theta is going to be the same no matter what we found, and the tangent of theta is also going to be the same no matter what we found. The reason that you were asked, however, to use identities to find sine and tangent in this particular question is because we're trying to start to become a little bit more familiar with how we use and manipulate identities, and we do that using actual values.